I hope screen is visible.
Yes.
All right. Hi everyone. I welcome you all to our MRP midterm presentation. Our project title is New York City Taxi, Limousine and Commission. So these are our team members. They are myself, Sriram, Sanket, and business analyst Amritpal Singh Sandhu. So this is about our Taxi and Limousine Commission project. What is it about? The organization in charge licensing of regulation, medallion, yellow and green taxi, and other things. So our project objective is like the goal is to use taxi trip data from New York City to pinpoint popular destinations and forecast total fare amounts. This analysis will optimize taxi management, guiding resources, allocations, and decision making for passengers, drivers, and city planners, etc. Incorporating a data warehouse concept will streamline the data management, facilitating thorough analysis, and strategic planning. So this is the weekly status report, and communications we did are through emails, phone conversations, messages, talked about EDA, WBS, and a lot of things. And this is about the internal meetings we had, discussed about the predictive modeling, cost analysis, and all. So activities done this week are we created the data pipelines in Azure Data Factory to populate fact and dimensional tables, and in EDA we created the Jupyter Notebook, and also made the graphs more readable and reliable for predictive analysis, and also for the user, and also star schema, also in the SharePoint updation and all. So as far as the current recommendations are concerned, it is about the updating SharePoint, timesheets, minutes of meeting, EDA, ensuring accuracy and accessibility, process diagram. And when it comes to data dictionary, the fields in our data that we have around 23 fields. That includes location ID and location, extra fare amount, improvement surcharge, payment type, and others are like tip amount, vendor ID, and a lot of things. And also mentioned about data type and description of what is it about. So when it comes to the project demonstration about the accelerated data analysis, it is an approach to analyzing the data sets to summarize their main characteristics, often using statistical graphs and other visualization methods. So it is a crucial step in the data analysis process. So in the initial stage of the exploratory data analysis, we are importing some necessary Python libraries such as Pandas, Seaborn, and Matplotlib. These helps us for Pandas helps in tabular data frame, and the rest helps us in plotting graphs, statistical operations, and a lot of things. So this is reading the CSV file from the dataset, reading the dataset. So this is how our data looks like. Store and forward, read code. These are our fields, trip distance, total amount, and all. So printing the data types, the data frame. So next step we are doing selecting the only desired columns and not all of them, so that it will be easy for our analysis. Also creating a new data frame, converting converting these types into date time format, and extracting pickup and route locations, calculating charges per kilometer. This is an additional column which we have added because it will be easy for us, because also the trip distance varies, so it will be beneficial for us. uh, this is a printing the new data frames as far as our analysis is concerned. So this is the statistical description of our data: count, min, max, 25%, 50, 75%, maximum values in our data set. So for our new data, we have around 12, 1 to 12,000, 1,28,050 records, and 14 columns. So also we have removed some null and infinite values from charges per kilometer column, new data frame. This is how it looks. And also plotted some visuals and graphs for analysis. This is a box plot of passenger count. So for majority of the cases, the passenger count is between zero, only one, and rest of the cases there are around four, six, eight also. So next we plotted histograms of, based on our vendor frequency, histogram store and forward flag with a frequency, pick up location IDs with a frequency, drop off location IDs with a frequency, payment type with a frequency, and trip type with a frequency. Around 6 to 7 histogram plots we have done. And then we have also plotted scatter plot, which is between the pickup location IDs and average charges per kilometer. So for majority of the location IDs, the charges per kilometer is all same around zero, zero to between 0 to 500, but majority is zero only. And this is the scatter plot between the drop off location IDs and average charge per kilometer. Here also it's the same case as before. So next we have grouped the passenger count and calculate the average charges per kilometer. Here we have grouping the fields here as well. The group by payment type, pickup day, drop off day, flags, and calculate the average charges per kilometer. And also we have plotted bar graphs for average charges per kilometer by payment type, average charges per kilometer with the day name, pickup day name, drop off day name, and store and forward flag. These are our visuals. And we have also done the bivariate analysis, trip data versus the charges per kilometer. Also the heat map explaining like how these two columns are more strong related, like drop off location ID and total amount, trip distance and total amount are highly uh, related. So next part will be continued by our developer. Sanket, go ahead. Yeah.
My name is Sanket. I am developer of this project. So this is the data warehouse part. For data warehouse part, we are using Azure technology tools and technologies. We are using Azure Databricks for computation purpose, and Azure Data Factory for creating the pipelines and scheduling the them and job orchestration. And for storing data, we are using Azure Data Lake. And for analysis purpose and to connect for reporting, we created Azure Synapse. So this is our project architecture. So our raw uh, will come in bronze layer in data lake, and it will eventually process to the silver layer and to the gold layer by using Databricks, and all job will be scheduled in Azure Data Factory, and finally data will get loaded to Azure Synapse, and we have Power BI reports on top of that. So I created the resource group in Azure, and this is Azure Databricks, and this is Azure Data Factory, and this is also Azure Data Factory. So this is Azure Data Lake. So this is the bronze layer, gold layer, silver layer. So yeah, for data modeling purpose, I am using the star schema. So in star schema, our fact table will connect it to the dimension table. So directly, and there will be no dimension table will not get connected to another dimension table or any other table. So this will be very helpful while doing the reporting, so that whenever we filter based upon the column in dimension table, it will filter that records only in fact table. And I created the dimension and fact tables uh, in Databricks notebook. This is my Databricks notebook. So here I am creating the data frame. Here I am mentioning the explicitly the dim trip type. So we have two kind of dim trip type, trip ID and their description. For trip ID 1, it's street help, and trip ID 2, it's dispatch. Finally, I'm writing to the gold layer, and it will eventually get loaded to the uh, Azure Synapse, and there is Power BI reporting on top of that. Similarly, I have code for the silver table. So, this is our, there are two kind of data. So we have green taxi data and yellow taxi data. So, so, silver table will read data from the staging table, and it will get data from the raw layer, bronze layer, and finally it will write to the silver table. So in the silver table, we are processing the data, and we are overwriting the data each and every time. And from the silver to the gold, we are doing append operation over here. So we are following the standard Medellin architecture. recommended by the Databricks Spark. So this is our fact table code. So we are just reading the data from the silver layer and we are appending the data in the gold layer. So we are doing incremental load, and these are the pipelines. So utils function will pre-compute the functions that is used for in the notebook, such as writing to data lake and integrating the data lake with as Databricks and mounting. So when we trigger the dimension pipeline, so it will populate that table. Similarly, we have pipeline for loading the fact tables. So first step in that will be utils, like pre-processing the function and loading the raw data from the bronze to the stage layer. From the stage, it will silver notebook will process it, and finally it will uh, execute the gold table, and it will delete the stage. In case if the silver loading to the silver got failed, so it will take back data from the stage to the bronze. So this way it will ensure that there is no data loss. And for reporting purpose, I'm connecting the fact and dimension tables. So in the raw table, we just have uh, IDs with respect to the dimension tables. Like suppose like here is the payment type and description. So in the raw table, there is no description. So here I'm connecting the fact table with dimension tables, and I'm generating the file for EDA analysis in Google Colab, and I'm writing it to the gold layer, and finally I'm exporting the result, and I'm importing in Google Colab, and I'm analyzing data over there.
So I have a graph here to show you. It displays information about histogram. This histogram uh, includes the information about vendor. This histogram explains that the vendor has the highest frequency as compared to creative mobile technologies. And the other histogram, it shows store and forward. The histogram explains that the flag, not a store and forward trip, has the highest frequency as compared to store and forward trip. So I have a graph here which explains about the trip type and payment type. This graph, the first graph explains that the street haul trip types is the highest frequency and dispatch type is of the lowest. The graph, the payment graph displays, this graph explains that the first highest preferred mode of payment is through credit card and second is cash. The rest methods, no charge, dispute, and negligible frequencies. Next.
So this is the scatter plot.
And this is a scattered plot. In the above scattered plot explains that the average charges per kilometer is between 0 to 250 for the majority of pickup locations ID. ID 50 has the highest average charge per kilometer. And this scatter plot charge of location IDs versus average per kilometer. The above scattered plot explains that the average charges per kilometer is between 0 to 80 for the majority of drop-off location IDs. Average charge per kilometer is 300 for drop-off IDs that are 250 plus. So in this chart, average charges per kilometer by payment type and average charge per kilometer by pickup day name. The first bar graph indicates us that the bar graph explains that the average charges per kilometer is 20.43 highest for cash and 5.43 lowest for dispute. And this bar graph explains that the average charges per kilometer for pickup is 24.10 on Sundays and 16.14, which is lowest on Thursdays. Next. Can you go to the final report?
Yeah, sure. You can tell about the predictive analysis.
Okay. So about the final report, ultimately our final report will include several important metrics: total revenue generated from these trips, total taxes collected, the number of passenger carried, the average time for each trip, and details about both pickup and drop-off location. This insight will help us as a comprehensive understanding of the trips and help us to make informed decision moving forward. Thank you.
Yeah, we also have predictive analysis in the future upcoming weeks.